Okay, let's talk about our second lesson in Unit 3, which is going to be solving equations with like terms. By the way, for all those who have been begging me to use the very worst colors in my marker bag, here you go. I'm using gray, black, and brown. I know, it's a travesty. I don't know what I'm going to do with myself, but there it is. Okay. So again, go ahead and put your name and class period at the top of your notes. 2-6, this one's for you. Look at that. Y'all get the shout out today. One more. Ooh, she can't even spell her last name. It's, y'all, I'm going to be really honest with you. Right now, it is like 5:30, 6 o'clock Friday night. I'm tired. And I'm still up here at school. So, woo. Please do these assignments, y'all. Just please do them. Okay, so starting off in familiar territory, inverse operations. Y'all, we know this one. Inverse operations are operations that undo each other. That's the worst underlining I've ever done in my life. Congratulations. They are operations that undo each other. They also could be called opposites. Just like you can undo going up by going down, you can up and down are opposites. So the inverse operation of addition. In fact, I'm going to see if you can fill it out on your own. Addition, subtraction, multiplication, division. The inverse of addition is, yes, subtraction. The inverse of subtraction is addition. The inverse of multiplication is division. And the inverse of division, shockingly, is multiplication. I know you didn't see that one coming, huh? Okay, go ahead and pause the notes right there, or pause the video and catch up with those notes if you need to, while I switch to my other weird color. Okay, this guy is back, y'all. He's back. So remember how we talked about when we have order of operations when there's not an equal sign? We have PEMDAS, where we go in this order. But now that we're solving equations, a lot of it is undoing operations, right? So we started going in this direction. We're not going to keep going up this time. We are going to work a little bit more with the adding and subtracting end of it, but I just wanted to kind of remind you where we are. I don't know why that piece isn't in focus. I'm so sorry. I don't know what to do about it. Okay, so you guys are familiar. Last time, remember, we did our adding and subtracting and multiplying and dividing. So we looked first for anything we could add or subtract, and then we looked for anything we could multiply or divide. Remember, the goal is always to isolate that variable. On these, remember, we were crossing that equal sign. So we were taking like a -2 from here, and we were adding 2 to both sides. So we were crossing, we were doing stuff to both sides of the equation. Today we're going to talk about stuff that does not cross the equal sign, stuff that is just on one side of the equation or another. I know, you're like, but Miss McNabb, you told us if we do something to one side, we have to do it to the other. It's okay, we'll figure it out. And today we're going to start by working on combining like terms. This is the little diagram I have for combining like terms. That means if I have 2x and 3x and 7x, I can combine all of those into 2 plus 3 plus 7, and that gives me 12x. Or you could just remember that it's taking all the things and combining them. Okay, go ahead and pause, get those notes if you need them. Okay, let's do some examples, shall we? Miss McNabb is getting her key out so that she doesn't have to record this yet again, because, y'all, it's been real. Whew. It's been really real. Okay. Yep, she's a cheater. She has the key. Okay. So, example 1, let's look at it. 8y plus 2y equals 40. 8y plus 2y equals 40. Okay. Remember, we're looking to combine like terms, then add or subtract, and then multiply or divide. That's the order that we're looking in today. Okay, so I'm going to go ahead and draw my gate. Do I have any like terms here that I can combine? Shockingly, I do. Okay, so I can combine my 2y and my 8y. Why? Because they both have y's. So I go ahead and open up my parentheses. I can do 8 plus 2. I take those coefficients. Coefficients are the number parts. It's a plus because it's a plus here. 8 plus 2, y, because they're y's, equals 40. Now, I know it feels weird, right? You're like, why can we do that? Because remember we talked about equivalent expressions when we were writing our distribution equations or our distribution expressions with the algebra tiles on that Desmos activity, and there's different ways to write the same things. This still says the same thing. So we haven't really changed anything about it. We haven't changed the balance of our overall equation. We've just written it differently. But it's still the same. It still means the same thing. So 8 plus 2 is 10. Y equals 40. Oh, now I'm in familiar territory because now I have 10 times y. I can undo that with division. Divide by 10. Got to do it to both sides because these do cross the line. So I divide both sides by 10. My y comes down. And 40 divided by 10 is 4. Okay. So I can check that by putting it into Desmos, by putting in 8 parentheses. What's going to go in my parentheses? That 4, because that's what y equals. Plus 2 parentheses, again with the 4, because that's what y equals. And that when I put it into Desmos, it should equal 40. Okay. One more thing on this one, let's talk about what steps we did. So the first step we did was we combined like terms. And then, who knows what our next step was? We divided by 10. Go ahead and get that problem down. Hit pause if you need to. Play when you're ready to join us again. Okay, example 2. Let's see how we do. So we're going to look at combining like terms. Then we look for adding and subtracting. Then we look for multiplying and dividing. Now we go in that direction. Okay. So let's draw our gate. Oh, how fancy. We can combine like terms on a practice that's about like combining like terms. Fascinating. So I can combine my 6c and my negative 3c. That's a negative 3c. So in my parentheses, I'm going to start by combining like terms. I have 6 minus 3. C goes on the outside, equals negative 27. 6 minus 3, if I have 6 fingers down and I pick up 1, 2, 3, that leaves 3 of them. So I have 3c equals negative 27. Oh, now I know what I'm doing. Now I can just divide, because I want to get this variable by itself, I can divide both sides by 3. Those cancel out. My C comes on down. C equals, this negative 27 divided by 3 would be a fabulous moment for Desmos in your life to make sure we're getting those negatives correct. Or Miss McNabb could just tell you it's negative 9. Okay. And to check it, you go ahead and put 6 times negative 9. That negative goes inside your parentheses. If it goes outside, Desmos is going to try and just subtract them. 6 times negative 9. You can do this one of two ways. You can do minus 3 times C, or you can do plus, which I like always doing plus so that I always know what it is. So you could do plus negative 3. Woo. Miss McNabb, we didn't need parentheses there. Plus negative 3, negative 9. So this guy, imagine that parentheses is not there. So it's plus negative 3 times negative 9. When we put that guy into Desmos, it should equal negative 27. I'll give you a hint. It does. And I'm going to rewrite that just so we have a clean version. We have 6 times negative 9 plus negative 3 times negative 9. Close those parentheses. So do we see our negative 9s just replaced those C's? Our first step on this one was, again, to combine like terms, and then we divided by 3. Go ahead and pause if you need to catch up. Okay, example 3. Oh my goodness. Oh my goodness, y'all. The variables are on the other side. I can't do it. Can't do it. Cannot do it. It's okay. Still have the same rules. We have to combine like terms. We have to add and subtract. And we have to multiply and divide. Okay. Draw our gate. It's okay. Just because our variables are on a different side, we can do this. We have our same rules. We know our rules. We can use our rules. Okay. So I can combine my negative 4x and my negative 3x. So I'm going to go ahead. This side I know is going to stay the same. So I'm going to go ahead and do it. 21 equals. On this side, I'm going to take my coefficients, negative 4 minus 3. So I took my negative 4, my minus 3, x. Okay, so now this equals 21 equals, okay, these are both negative, so I'm going to use, it's going to be a negative answer. And I know that 4 plus 3 is 7, so it's going to be a negative 7. Or you could use Desmos. Negative 7x. Okay, so now this is familiar territory here, because I know here I have negative 7 times x. I know what to do. I can divide both sides by negative 7. Okay, this one right here is a great moment for Desmos. 21 divided by negative 7. That's going to give you negative 3. I always recommend, guys, if you have negatives, just use Desmos. Just use Desmos. So negative 3 is going to equal, these negative 7s cancel out. That x comes on down. There you go. Negative 3 equals x. Or x equals negative 3. They both mean the same thing. To check it, let's see if she can get it right this time, y'all. Now we're going to be putting our amount into this side. So we have negative 4, open parentheses, negative 3. So this says negative 4 times negative 3. Remember, I like to always plus, no, I don't. Oh my gosh, y'all. Yes, I do. So sorry. Plus, this is going to be negative 3 times negative 3. Guys, the reason that this plus doesn't matter is because we can always consistently do a plus then. And if I have plus minus 3, go ahead and put that into Desmos. It'll come down and tell you minus 3. So this means the same as this. Okay. So -4 times -3 plus -3 times -3 should give you 21. And it does. Our first step on this one was, again, we combined like terms, and then we divided both sides, not by 7, by -7. Those negatives are important, y'all. Okay, go ahead and pause, do a little catch up if you want. Okay, I think we're ready. Last but not least, example 4. Whew, they put it back on the right side, y'all. Thank goodness. Whew. Okay, it's not like Miss McNabb made these notes or anything. So first off, we're going to combine like terms, then we're going to add and subtract, and then we're going to multiply and divide. And our whole goal is to get our variable by itself. Okay. Draw our gate. Oh, I think I messed up on the colors. Oh well. Okay, so this one's brown and that one's brown. It's, life. Okay, so I can combine my 16W and my -10W. So I have 16 minus 10W equals 24. 16 minus 10, great time for Desmos in your life, or Miss McNabb could just tell you it's 6W equals 24. Okay, this is familiar territory. I can divide both sides by 6. I can cancel those out. My W comes down. W equals 24 divided by 6. Great moment for Desmos, or Miss McNabb can just tell you that it's 4. And to check this, you would put it into Desmos. Now, if you don't want to deal with the plus and everything, I'm going to show you how to do it this time. So this is without dealing with the plus minus situation from last time. If you want to just do it a different way, you can. So you're going to do 16 times 4, and then minus 10 times W. And our W, again, is 4. It only really becomes a problem when you've also got a negative here, and you have to remember to multiply -10 times -10. That's where it gets really goofy. So, or -10 times -4. So, but if you want to do it this way, you can do it this way. See how it works for you. And that should, if you put that into Desmos, it should equal 24. And our steps on this were, we combined like terms, and we divided by 6. Ooh, Miss McNabb, what is that? Divided by 6. Okay. Go ahead and get caught up on those notes if you like. Okay, once again, you do have 4 practices. I believe in you. You got this. You can do it. Woo woo. And once again, if you need to check on a copy of the notes, you can always look in the Unit 3 folder. Thank you guys so much. Have a great day and good luck.